All right, so to go back to example 8, it's a piecewise function. What we did is we graphed the parabola separately, and then we graphed the radical function separately, and then we combined them, okay? In the future, we don't want to have to graph the entire graph of each piece just to combine them. We're going to be graphing just the particular piece on the defined interval. Now, of course, once we had the graph, it was easy to determine what the if it was continuous at 1 or not. 1 being the point where it exchanged from one graph to the other. The limit from the left was 0, the function value was 0, and the limit from the right was 0. Since 0 equals 0 equals 0, you got to say all three. F was continuous at 1. Okay. Now, how are we going to be able to do that in the future quicker, more quickly, without sketching the graph? I'm going to show you. Okay. When you want to find the limit from the left-hand side of 1, left-hand side of 1, left side of 1, left of 1 is less than 1, right? Would you agree? Yes. Less than 1 is left of 1. They both have the la 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 sound as well, right? Left of 1 is less than 1. So watch this. If I want to know what the limit is as x approaches 1 from the la 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 left, and 1 is the point where it's exchanging, all you got to do is plug in your 1 into the piece that's the less than piece. Direct substitution. Watch. What do you get when you plug it in? 1 squared is 1, plus 2 is 3, 3 minus 3 is 0. And that works because if you remember how we got the graph right there by knowing what the y value was at 1. So if you want the limit from the la 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 left of an x value, plug it into the la 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 left side. Okay, good. Now, if you want to figure out f of 1, that should not be any surprise. When it's f of 1, that is which piece actually has 1 defined. That's the equal sign, right? And in this case, that's still the top piece, right? When it's less than or equal to. So the function value is equal to. Let's try it again. What do you get when you plug a 1 into the equal piece? 1 plus 2 is 3. 3 minus 3 is 0. Kaboom. Nice. Now, the last one. What if you wanted to find the limit from the right-hand side? Right-hand side is greater than. Right, greater. They kind of have the sound, don't they? The greater than piece. Which piece is the greater than, the top or bottom? The bottom. So look what happens if you plug a 1 directly into the greater than piece. 1 minus 1 is 0. The square root of 0 is 0. 0 times 2 is 0. Now we have all three of our values without the graph. Okay? That is something else. And we know why it works. It works because that's exactly what we did when we sketched the graph. We just don't need all those other y values. We're only interested in the ones at 1, right? Does that make sense? So let's try it out now. Now let's try it out on letter B. Let's go ahead and get our notation set up first, okay? We want to know if it's continuous at -2. So we're going to look at the limit as x approaches -2 from the left of g. We're going to look at g of -2, and then we're going to look at the limit as x approaches -2 from the right of g. So we still get all of our notation, but rather than set out to graph it, let's go ahead and use our little trick. I'll use the same color. If I want to know what the limit is from the la 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 left, la 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 left is la 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 less than, right? You don't even need the la 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 sound because you know on a number line, on a horizontal number line, left of is to the left is less than, right? That's where the smaller numbers are found, right? All right, so come up here. Which piece is less than, the top or bottom? The top, right? There it is, less than. Let's use direct substitution. Even though there's no equal sign there, It doesn't really say to use it when it's an equal, but we're looking for the left-sided limit. So less than, plug it in a -2. What's 6 divided by -2? -3. Guess what the limit from the left is? -3. Wow. G of wait, road, bridge, road. We don't do bridge, bridge, road, road, bridge, right? G of -2, that's the equal sign. The function value is go stand there. Which piece is equal to, top or bottom? Bottom. See, there's the equal sign. Use direct substitution. What do you get? Well, -2 squared is +4. Half of 4 is 2. 2 minus 3 is -1. Very good. Boom. Now, if we were checking for continuity, it would be game over right now, wouldn't it? Because these two don't equal each other. But to be thorough, let's go ahead and finish what we started here. The blue is the right of, okay? From the right, right is grow, greater than, row, right, grow, greater than, row, right, ask, row, rows, right? And as Brady already said, the greater than is the same as the equal piece, right? They use the same piece. So you don't have to use direct substitution again unless you just want to check your work, but we will get -1 again, all right? There you go. You don't need to sketch the entire graph to answer this question. Now we can follow up with our concluding sentence just like we did on the quiz, right? Since or because -3 does not equal -1. Does it matter which -1 we're citing here? No. Okay, comma, G, the function is G, not F. G is not continuous at x equals -2. All right. Now, for kicks and giggles, we don't have the graph this time, do we? Can we still determine what type of discontinuity we have?
Yes.
I hope so. What type do we have?
Jump.
A jump. When the two one-sided limits are defined, they exist, but they're different, we have a jump. All right. So G has a jump at x equals -2. That's how we answer it. And now, can we find the general limit? Well, let's set it up. Let's set up. That's what that means when I ask you to set it up. Set up the general limit and evaluate it. Well, the general limit doesn't exist, right? Because -3 doesn't equal -1, so it's DNE. If I did ask you to justify it, now would it matter which -1 we're using? Yes, for the general limit, we have to equate the two roads. Okay, so those would be the two outside. But for continuity, all three of them have to be the same. So if any two of them are not, you take your pick. Okay, cool. Now, when you do walk up to this problem, you could probably make that determination right away. You could be like, oh, the left-sided limit is the top, but notice the bottom piece, because it's greater than or equal to, you can say right away, the limit from the right is going to equal the function value. Yes? The limit from the right is the same as the function value. It's the same company building those two. There you go. It's fun. It's easy. It's fun, easy. How do you like first period? Better? It's earlier, right? Okay.
I thought you were having your hand out.
All right. Yeah, okay, there you go. Boom. Fist bump. Paper covers rock. You win, Brady. All right, y'all have a great weekend. Go Astros, go Unicorns, playing East Central tonight. Should be fun.